Welcome and hello. This is a support video in HEC-RAS, and I'm titling this video Patchy Inundation Results. So what that means is if you have a 2D flow area like I have here on the map, and if I zoom in here, you can see that we have the water depth layer that's selected, and then we have water depth, and then all of a sudden there's no water, and then there's water depth again. This is what I'm calling patchy inundation results, and it just doesn't look very realistic. So what I'm going to do is describe how to prevent this from happening. Now, there's probably multiple causes. For instance, your terrain may be a problem, but more likely than not, the mesh that you're using may need to be improved, which is the case in this particular model. I'm going to go ahead and zoom out so I can show you a little bit more of the model. This is RAS Mapper, and then further upstream. Okay, I'm at the upstream end of the model. This is a storage area, and then downstream of our dam is a 2D flow area. I'm going to make this a little bit wider. And then here is the aerial map you're seeing in the background. I'm going to go ahead and toggle that off. So expand, toggle that off. And then here is the terrain, again, storage area, 2D flow area, and then here is the dam. The dam does exhibit a breach. So if I open up the geometric data editor, here is the breach data. If I click on breach, and then I want to breach this structure, so I need to check that on. Here is the breach profile, and then it's going to start on January 1st at 3 a.m. It's going to take 1 hour, and it's going to be a linear progression. So just wanted to point that out. Okay, let's go ahead and take a look at the results because this model has already run. And if I just scroll over to the beginning of the breach time period, this is using a 1 hour time step. So this is at 3 a.m., right when the breach begins. And then this is 4 a.m., and then 5 a.m., 6 a.m., and so on. I'm going to go ahead and rerun the simulation and focus on just this area. Now, using 1 hour time step, we don't have much of a problem. We don't see that patchiness, at least not this close to the dam, but we did further downstream. I'm going to click on this unsteady flow analysis button, which we can also get to by going to edit, unsteady flow analysis, and then just make a few changes. So for instance, we don't need to run the entire 2D simulation to address this problem. So I'm just going to go ahead and start this at 10 minutes before the dam breach. And then I'll just change it to the same day. And then let's just go for 2 hours. So we'll end it at 4:50. That's AM. And then for the computation time interval, again, this is something you would probably fine tune for your own model. But for this, I'm just going to change it to 2 minutes there. We want the mapping output to be smaller. So something like 2 minutes would be fine there. We'll keep that at 1 hour. And then also for the computation tolerances for 2D flow, I'm going to set it to a 1 hour look back. Advanced time step control, I'm going to adjust it based on the current number. So let's go 0.9, 0.4, and then here I'll go 3, 5, and how about 3 again? Okay, so click OK, and then click compute. Okay, it looks like it's adjusting the time step right now. Okay, so the results are in. There was a volume error, which we can address later, but for now, let's just go ahead and close this and take a look at the results. So we are back in RAS Mapper. I'm going to start the animation right here, 340, and just single click. Now you can see it's advancing at just a 2-minute time step, so that's a lot more precise than just 1 hour. It's 30 times more precise. And we are getting that same patchy water depth phenomenon that I mentioned earlier. So we don't really want that. I'm back here at, let's see, 4:12 a.m. and let's just zoom in here. This is what we want to avoid. So let's go ahead and address that. I'm going to edit the geometry. So I'm going to come over here to geometry, toggle on the geometry layer. So now we see our mesh and a few other features. Expand the 2D flow area and then click on perimeter and click on edit and then click on this edit existing feature and then right click. Now I'm going to click on edit 2D properties. And as you can see here, we have a 50 meter by 50 meter cell spacing for our perimeter, which is probably a little bit too large, especially for the main channel. So what we want to do, one option is to decrease this to something maybe 20 meters or 30 meters, or maybe even less. I mean, ideally, it should maybe be 5 to 10 meters, at least as small enough so there's about 3 to 5 cells that the main channel can flow across. The more the better, but then again, we don't want to be waiting forever for the computation to finish. So this one option, I could just change this to say 20. Click on this button, generate computation points. And then after that, we would have a refined mesh, a smaller mesh, which would take longer to compute, but it would also have much more realistic depth results. Another option, which is the option I'm going to do, is to add break lines. So if I click on break lines, the checkbox, and then I click on this layer, and then click on to add a new feature referring to the break lines, I'm going to sketch a break line from upstream to downstream. But before I do that, I'm also going to toggle on the results so I can actually, or just change the playback. Okay, yeah, so I can see the where the water's actually going without having to reference the terrain. Okay, so back up to break lines. Looks like it's already editing. So again, just a single left click to start the break line. So I'm just going to click around here. For the most part, just try to stay centered. Okay, it's going to pan over and just continue the break line. So right now, it looks like there's only about a 1 cell width, which is certainly not enough. Okay, I'm going to double click right here. I know this is not the downstream end of the reach, but we'll call it break line 1. Click OK. And then I'm going to click the Edit Existing feature. Then right click on my break line, Edit Break Line Properties. So this is our one only break line right yet now in the geometry, in the 2D flow area. And then for a size, let's go ahead and say 10 meters. So that's much smaller than the existing 50 meters. And then it's going to repeat 3 times on each side for a total of 8 on total across. So 4 times 2. And then click OK. The last thing we need to do here is regenerate the mesh using that break line and the cell spacing. That's this button right here with the little red line. Enforce the break lines. And boom, now you can see we have much smaller mesh and cell spacing along that break line. Okay, so that should work for us. We do need to address this cell with more than 8 sides. So let me just go ahead and add a computation point. Boom and boom. Okay, so that fixed that. I'm going to stop editing. And yes, I want to save my edits. So I'm going to toggle off the 2D flow area, and even the whole geometry is fine. Zoom out. We're going to rerun the simulation and then take a look at the results. Again, we're going to be focusing on, what did I say, 4 a.m. or 4:10. I come down here to the depth, and then right here at 4:12 a.m., this is the patchy water depth that we want to eliminate using our now refined mesh. We go up to Run, Unsteady Flow Analysis. We are set to breach once again, and we'll be using all the same values here. So I'll click Compute, and now we wait a while. It first has to regenerate the hydraulic properties table, the geometric preprocessor, because remember we have a new geometry, a new mesh. Okay, this is the 1 hour look back period that we added to the computation tolerances and options. And then now it's actually running through the simulation. The first part of the simulation was really quick because that was before the dam breach. There was nothing really to calculate. But now that the dam is breached and there's overland flow downstream of our dam, there is a lot more computations to take place. So that finished up. Let's go ahead and take a look at the results. And then here is the animation playback, 350, 4 o'clock, 450. Yeah, much smoother. Let me go ahead and dial back to our specific time right here. So sorry, 4 o'clock, 402, 404, 406, 408, 410, 412. This was the 412. Believe this is the same time step we were looking at. 414, 416. Very smooth and continuous. We don't have patchy inundation results, which was the whole purpose of us doing this particular support video. One reason why I know that it's not a problem with the terrain is I can actually sketch out the terrain just by clicking this button here, holding them, and just sketching from upstream to downstream, and then do a double click, and then click on Plot Terrain Profile Fast. You can see we have a constant downstream slope. It's not like there's ponds along the course of the river, so that was not a problem, but certainly we got that problem fixed by modifying the mesh. If it comes down to decreasing the cell spacing of the perimeter versus adding a break line, I typically think adding a break line is better. There's going to be fewer total cells, but again, that's sort of up to the modeler to make a decision. All right, hope that was helpful.